In this section, text classification, we are going to learn about the prediction. What is the type of prediction in text classification? And then we are going to look at the definition of the text classification and some of the use cases of text classification. And I'm going to discuss about the text prediction, text classification variants, and some algorithms. In the prediction, or we call it the text prediction, there are two kind of prediction. The first is condition prediction and unconditioned prediction. If it is unconditioned, it means there is no condition. Okay. Unconditioned means no condition. If it is no condition, then you will just predict based on the probability of a single variable. So you just use P X. It means this is the probability of X. If it is a condition prediction, then you need to predict the probability of an output variable given an input. So I'm going to predict Y given X. So there are some input on X, and then this input will do the prediction about Y. So there are some concept about the prediction for the unconditioned and the condition. So we will take a look one by one. We have left to right autoregressive prediction. We have left to right Markov chain. We have independent prediction. We have bidirectional prediction. For the condition prediction, we will take a look only to the autoregressive condition prediction and non-autoregressive condition prediction. So let's take a look on the first. This is about the unconditioned prediction. The unconditioned prediction, as we know, it is only the probability of a variable x, for example. One of the method is autoregressive. We call it autoregressive model. In the autoregressive models, it generates text by predicting the next word. The next word means the if we have one sentence, so we can check what will be the next word. Sometimes we call it the next token in a sequence based on the words that have come before it. So if you look at these figures, so the autoregressive left to right means we have the black color. So the black color, it is something that we know. So this is the text. And we want to predict the orange. We want to predict the orange. We call it this is left to right because the xi, it is the orange color. And we want to see the possibility of the previous words. Given the previous words, what is the prediction for the word in the position I? So we have this multiplication. Okay. So this symbol means multiplication. So you already learned last week on the method to predict the text is using the multiplication based on the previous words. So let's take a look at the example. If I have an input sequence, the cat sat on the something. So we need to predict what will be the best word in this blank. So the prediction, the step one, based on the input, the model might predict math. Maybe math would be the best as the next word. So the cat sat on the mat. And then after that, we have this sentence. So after generating the mat, the input becomes full sentence. The cat sat on the mat. And then there will be another question. What will be the next after mat? So the prediction in the step 2, if we want to continue generating the text, then the model predict the next word based on the full sentence and perhaps something like and. So maybe the cat sat on the mat and so because we already predict this one, then there will be another question. What will be the best next word? And so on. So we will keep continuing about the next word, the next word, the next word until we have the desired length. The desired length means if I have the limitation, maybe let me create in one sentence, maybe 10 words. Then after we have the 10 words, we stop. Or encounters a stopping condition. So if you have the stopping condition, let's say you make only 5 lines. Then after you generate sentences in 5 lines, you stop. So those kind of things, yeah, we can use the autoregressive model. The other kind of prediction, we call it the Markov chain. The Markov chain, it is a stochastic model that predicts the next state or the next word based solely on the current state without considering the previous states. So if you look at the text generation, so the model generates text based on the probability of a word occurring after the current word. So what does it mean? If you look at this figure, we want to predict the orange. We want to predict the orange color. But in order to predict the orange color, we do not need the full sentence. So you can see here, there are some white. So I don't need the full sentence to predict in this state. I don't need the full sentence to predict in this state. So I just need to know the probability of a word occurring after the current word. So you don't need to do the entire sequence. Entire sequence means all the sentences. If you already learned from the previous section, we have the bigram. So if we use the bigram means this is the first order Markov chain. The first order Markov chain means we want to look at the previous word. So only the previous one. Then we have xi given that the xi minus 1. The second order Markov chain, it is equivalent to trigram. It means I have the xi. I want to know what is xi given that the xi minus 1 and xi minus 2. So we have the first order means only based on the previous state. The second order, so 2 times, then it means we use the trigram. So we can look at this kind of, so you already learned about this kind of matrix. Let's suppose we have the corpus like this. The cat sat on the log. Using the bigram, you can generate this matrix. So after the starting of the sentence, there are two the. After the one sentence is followed by cat and the other sentence is followed by dog. After the word cat, one sentence is followed by set and so on. Then this is the transition matrix and we can use the bigrams. From the, we can go to cat or dog. So if we have the, we can select either it is cat or dog and the probability is 0.5, 0.5. After cat, so we can go to set because there's only one. So the probability is 1. After set, we can go to on. After set, we can go to on because only 1 and so on. Then we can set up this probability. After we know this probability, then we can again do the multiplication. So this multiplication, we learned from the previous section as well. The other kind of prediction, we call it the independent prediction. With the independent prediction, so it refers to a model ability to predict its token in sequence without considering the context provided by the preceding token. So its prediction is made based solely on the characteristic of the token being predicted. So for example, if you look at this figure, I want to predict this sentence. Then it means I will just use the probability of this word. I want to use only the probability of this word. I will use only the probability of this word. So this is the independent prediction. We will get the P of xi and then we do the multiplication. It often uses statistical methods or features extracted from the data rather than any sequential relationship. So usually we can get the features. For example, you can get the TF-IDF, you can get the frequency, and so on. So the use case, we can do the mass language modeling. We are going to predict the missing words in a sentence. So we usually use this one. Later we will learn about the language modeling such as BERT and other things. So they are using the mass. Text classification. So the text classification is also one of the way to do the text classification is using the independent prediction. Question and answering, so like the chatbot. So we can also do with the independent prediction. So the independent prediction means we have a kind of frequency. So let's say we have the corpus, the cat set on the mat, the dog set on the log. Okay. So the vocabulary that we have is cat, dog, mat, log, set, on, the. Okay. So we can calculate how many the are there in our sentence. So let's assume that this one has been lower. Lower means lowercase, it is to make it into sumunsa. Lower. Then this the and this the, they are the same. Then there are 4 of them. What about cat? We have 1. What about dog? We have 1. What about set? There are 2. What about on? There are 2. Mat, we have 1. And log, we have 1. Then we can see the probability distribution. So the predicting the next word, we simply sample from this probability distribution. So for example, okay, the probability of is 40% of the time because we have 0.4. What about set? Okay, set is 20%. So it is regardless the preceding words. So the simple one is just like this one. I have a sentence like the dog said. Then just for the simplification, we will just do the multiplication 0.4 for the dog. It is 0.1 and then set 0.2. Then the word the dog said has the probability 0.008. For the dog lock, so we can see the is 0.4, the probability of dog is 0.1, and the probability of lock is 0.1. Then we can get the value 0.004. Okay. Then the highest probability is the dog set. Then we can make sure that this sentence might be better than this sentence. The other kind of prediction, we call it bidirectional. Bi. The word bi means two. You can go to the right, you can go to the left. So bidirectional prediction, it involves using the context from both the left and right side. Okay. We want to know what is the left and we want to know what is the right side of a target token in a sequence to make the prediction. So this approach allows the model to capture dependency from both directions, enhancing its understanding of the context and improving the quality of the prediction. So the use cases, we can use the BERT, mass language model such as BERT, fill in the blank. So if you have the word, long word, so let's say this is a blank, then what is the possible word in this position? And there's also the semantic understanding. If there is any word missing or if there is any word which is not clear, then we can replace with a new word which is similar in the meaning. So in the bidirectional, the orange color, the orange color is the position that we want to predict, and the black color is the position that we want to use to convince us for the prediction. So we say that the xi, we want to predict the xi given that any x that is not I. So the x that can be before I, and for any x that is after I. So any of the direction can predict the word in the position I. So this is an example. We want to predict what is a missing word in a sentence. Predicting a missing word in a sentence. So the input sentence with mas in Korean, kawang. I'm not sure what this. So let's see. In order to train the model, we provide the sentence with missing word and replaced by a special mask token. So usually when we do with the masking, so the word is masking, we put the token. The token is like this one with the square bracket, and we put mask. So for example, the cat sat on the mask. So this is something that we want to predict. what would be the best word in this location? What would be the best word to fill in so that the sentence becomes good? So the cat sat on the something and looked at the dog. And we will use the information from here. We will use the information from here to predict what will be the best word for this one. So in the bidirectional context means, yeah, we want to look at the entire sentence and use both the left and the right. Yeah. So in the left context, this is the left context, the cat sat on the, and the right context is, and look at the dog. So we have this right, this is the left. Then maybe the possible prediction is a place. So let's assume that the place is on the mat. Then the cat sat on the mat and looked at the dog. Then if it is the highest probability among the other option, we will choose this option. In terms of the condition, so all the previous part, it was unconditioned, but now it is condition. So condition means we have a condition. We have a kind of X or some. We call the autoregressive prediction. So the model generates its token word or maybe character in a sequence, and it is influenced or guided by external input. External. It means something which is not in the text. Or maybe it is related to some context. So the external context create the condition for the model's prediction. So for example, here we have a sentence that we want to predict. So I want to predict the orange color. I want to predict the orange color. So I'm going to look at what is the previous word. I'm going to look at what is the previous word, what is the previous word. But not only this one, I'm also looking at the other kind of data, which is the sources. Maybe if it is related to sports, then we will use the information about sports. If it is related about music, then we use any dictionary or corpus related to music on this text. So it means the output depends on both what was generated previously and the additional information provided. So that's why whenever you use the, if you use the ChatGPT or if you use Gemini, you always need to provide the context. Okay. The context means, yeah, the ChatGPT needs to know what are you going to ask. If it is related to the data science, then you need to say that I'm going to ask about the algorithm in data science, because the algorithm in data science might be different with the algorithm in manufacturing. Okay, so the context is different, then the answer also will be different. So that's what we call it the X or the additional information. In the condition prediction, it is very common for the text generation. Okay, if you look at the ChatGPT, yeah, usually we auto-regressive prediction. You need to have the text. Let's say this one. So the model generates the next part of a story based on the input. So I write this one. Once upon a time, there were three little pigs. So we want to ask the GPT or any kind of modeling, text modeling. So what would be the next story? Then the step one is the model is conditioned based on the prompt. So it predicts the next word based on it. Maybe we can predict there were three little pigs. So maybe the next word is who. And then based on the once upon a time, there were three little pigs who. Okay. Because three little pigs is somehow it is well-known story. And they know that this kind of story is related to the old stories. What is in Korean? Kweji Samyongje. Okay. So because it is a famous story, then yeah, the prediction directly predict the next word is built. Then the model continues predicting words until it completes the sentence, like this one. Once upon a time, there were three little pigs who built houses to protect themselves from the wolf. Okay. So this is the autoregressive based on the probability on its data and based on the context given X. There is another kind of uh, use case for the autoregressive prediction. It is for the machine translation. When you translate 통역. For example, I want to translate from English to Korean. And we know that the grammar between English and Korean is different. So suppose there is a sentence, I love eating apples. So the model is conditioned on the input English sentence. So I want to translate this sentence into Korean. How? And the step one, because in the translation, we will start from the left to right. Yeah, if it is based on the English. Okay. Of course, there's another kind of words or there is another kind of sentence which is using right to left. For example, if you learn Arabic, then it is from the right to left. Okay. For some books, the old books also in Korean, they use the right to left. Okay. Then by looking at the sentence, I love eating apples. So I start from the subject I. Then I can predict that the Korean translation is Nanan. And then the step two, I look into the next word, which is love. And it predicts sabar. Why? Because we know the context. Okay, the context X in this case, we know that it is about Korean. In Korea, the subject will be followed by the object. So we will predict the object comes before the verb, and then at the end we predict the verb. 먹는 것을 좋아해요. Then 나는 사과를 먹는 것을 좋아해요. Then this is the prediction for the translation from this one. There is another kind of condition prediction. We call it non-autoregressive prediction. If it is non-autoregressive, It means I will just predict this orange color. It doesn't care about the previous word. It doesn't care about the next words, but I will just use the probability of that particular word. So the model generates all the tokens, words or phrases simultaneously rather than generating them one by one in autoregressive model. So if you look at the autoregressive, so we will make two words, and then we will make three words, and then we will make four words, and so on. So this is the autoregressive. So we know that there are two kind of things, okay? Autoregressive and non-autoregressive. So the autoregressive means it is like writing a sentence word. So after you know two words, then you will check the next word, and then you will check the next word, and then you will check the next word, and so on. So you start with the first word and then move to the second and keep going until the sentence is complete. For non-autoregressive, it is like typing the entire sentence at once. So if you know autofill, okay, if you use the Gemini for coding, okay, maybe you type import and then it automatically to show you if you just type import, then there will be some autofill. Next is pandas SPD. So it is automatically performed by the the GPT to fill in the missing word. Okay. So in that case, yeah, we can say that it is a kind of the non-autoregressive because we already know what will be the best next sentences. So you don't need to go word by word. So the system instantly give you the entire sentence. Yeah, so this is the non-auto-regressive. By looking at those things, now we need to understand about the text classification. If you learn the data science, the data mining, we know the word classification. The classification means, yeah, we need to organize the text into one or several predefined categories. In the literatures, you may also look at the text classification with another kind of knowledge. For example, maybe they said text categorization. Basically, they are the same. Document categorization. So they are also the same. Or document classification. So they are the same. Yeah, one good example is the spam classification. If you use Gmail, or if you use Naver, or if you use any other email, so the email, they will have a tool to classify whether the email that you receive is a spam or not. Category. The category is spam or not spam. If a spam email comes to your inbox, then it will go to the spam folder. If non-spam email comes to your mailbox, then it goes to the inbox. So this is the classifier task. Then there will be two classes, inbox and spam. So the class is spam or not spam. So it classifies any email into primary or spam. So document classification from the academia. From academia means we are from the university or from the research. So if I have document, I will take a look. Okay, the document is related to health. But in the health, there are many other sub-classification. For example, whether the document is about dentists, whether the health is about the health professions, or the document is about medical students, or the document is about medicine, nursing, pharmacy, toxicology, and other things. Or if the paper or non-moon is related to life science. So in the life science, there are many other categories. For example, the agricultural and biology. Or maybe it is related to biochemistry. Or maybe it is related to the environmental science, and so on. If the big category is about physical science and engineering, so there are many subcategories. If it is also about the social science and humanities, there's also another subcategories. So this is the category that we can use for the text classification. In the social listening, okay, they call it the social listening. Whenever you have complaint, and then there will be a text classifier, and it will classify you. Okay, this is about complaint. Then this text will go to some kind of department. If this text is about the product question, okay, it will go to maybe marketing department. If this text is about the competitors, then yeah, it goes to maybe the product engineering department. If the text is about the content performance, then it will do something. If it is about request, then it will do something. There's also another kind of the categorization. We want to categorize the support tickets. So for example, if you have problems with the software, okay, so usually we use the ticket for software. If you buy a software and then you have problems with your software, then you will send tickets. Sending the tickets means you will send a kind of request, and then the text analysis will check whether it is about billing. So maybe it is about the payment, or maybe this is about the feedback. So maybe the software feedback, or maybe it is about question how to use the software, or maybe it is about the complaint. So what about the errors in the software? So this kind of classification, you can build some kind of a module for the classification. Sentiment analysis. So this is the most common approach. So you have the word or you have the sentence. My experience so far has been fantastic. Okay, because I know that this word fantastic is a good sentence or a good word. Then this might be a positive sentiment. The product is okay, I guess. So the word okay is something not clear. When we do not know whether it is really good or it is really bad, then we can make the category neutral. Your support team is useless. Okay, then it is negative. So using this kind of thing, then it means the class, there are three. The class positive, the class negative, and the class neutral. So we already learned about this text classification before. Yeah, if it is two class, we call it binary classification. So I hate this movie. So I can set whether it is a positive or negative, because the word hate, then it is negative. So binary classification, we have only two classes. Multiple classes. So it means more than two classes. I hate this movie. So it can be very bad, because the word hate is very, very harsh, very, very harsh. Then if we have five classes, yeah, this is more than two, because there are five classes, then it is multiple classes or multi-class classification. The Korean economic increase. So you want to classify into some topics. So maybe this is about the economics, then yeah, we put the class as economic. But we have another class, finance, sport, international, entertainment. So it means the class is more than two, then it is multi-class classification. So the text classification can also be done by the translation. Okay, so we can classify whether I is in the pro, pronoun of the, or we call it, this is the subject. Okay. It. So we can classify whether it is the verb in the basic form, or the verb in the history form, or the verb in the third form. This, it is the determinant. So we can classify whether this is in the PRP, or this is in the VBP, or this is in the NN. So we can do that one for the text classification. So the idea is we have X. Okay. We need to extract the features, which is X, and we need to predict the label Y. So I like peaches. Then I need to extract the features. After I extract the features, then predict. Okay, because I have the word like, then it is positive. Or if it is the sequence labeling, I like peaches. So I extract the features. Then I can do the prediction. Okay, this is the pronoun, this is the verb, and this is the noun. So we can do a lot of things for this text classification. Okay, so I think I will stop here. So we can continue tomorrow, and we will discuss more about the algorithms. Any questions?